Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2018 Specialist Maths Exam 1. Like always guys, before I start this video, if you guys want private tutoring in specialist methods, physics or chemistry, you can always email me through this email. And yeah, let's smash through this video. So question 1. Two objects of mass 5 kilograms and 8 kilograms are attached by a light inextensible string that passes over a smooth pulley. The 8 kilogram mass is on a smooth plane inclined at 30 degrees to the horizontal. The 5 kilogram is hanging vertically as shown in the diagram below. On the diagram above, show all the forces acting on both masses. Okay, let's do that. So of course, for each mass, we're going to have the force of gravity acting downwards. So this is going to be 8g. This one over here, 5g. And okay, for this one, we're going to have a normal force. The floor that's pushing up, we're going to have a normal force. And we're going to have a tension force, actually, too. So a tension force is going to be, because we're on, like the string has tension. And these two tension forces should be equal. So they will use the same value of T. So T and T, these are both equal because they're all acting on the same string. And then, yeah, that's pretty much it. Done. Find the magnitude in meters per second and state the direction of the acceleration of the 8 kilogram mass. Alright. Normally, okay, let's take the acceleration for the 5 kilogram mass as going downwards. Like if this, gets pushed downwards, what happens to this one? It has to be pushed upwards. Let's take that. Okay, in this case. So, let's break them down into the 8 kilogram, let's break it down to its components. Yep. So what's going to happen? Well, we know this one over here, this force over here, is going to be, AG sine 30 degrees. This one over here. And this one over here is going to be AG cos 30 degrees. Okay. Now, okay. Think of it. So we're looking for only the 8 kilogram one. So if it's accelerating upwards, we're going to have, it's only going to be accelerating this way or this way. It's not going to be accelerating up or down because, yeah. So that means that N and this over here should be equal. So that's quite useless to know. But the only important part is this force and this force over here because they are parallel to each other. So this one goes this way, whereas the other one goes that way. So because overall that it's moving this way, we're going to take that as positive. So it's going to be, for the 8 kilogram one, it's going to be T minus 8g sine 30 degrees. So that is the force net equals mass, which is, what is the mass? Overall, it's 8 kilograms. So yeah, mass times your acceleration. That is your first equation. Your second equation, okay, can be taken from here. Now, we're taking acceleration as, positive. So it means we're going to say this because this one's downwards and it's going to be a positive. So this minus this. So 5g minus tension should equal to 5a. So mass times acceleration. And the acceleration is the same value for both. If this accelerates at a value, it has to be the same as this. So we've got two equations and we can solve for the acceleration. So if we add equation 1 with 2, we can actually get rid of those values of t. That will give us 5g minus 8g sine 30 degrees is equal to 13a. Great. So 5g, okay, minus 8g. Now sine, so it's like sine pi over 6, which is a half. So it'd just be 4g pretty much. This over here becomes just 4g. It's equal to 13a. That just gives us g is equal to 13a. Hence, your acceleration is g over 13 meters per squared. Now, okay, find the magnitude. We found the magnitude and state the direction. Okay, what do we know? We can see that it's a positive acceleration. What do we talk about when it's positive for the 8 kilogram? We took the positive as going up the plane. So your direction is up the plane. Nice and easy. Question 7. Show that 1 plus I is equal to this. Okay, so we just want to convert it to polar. So what we're going to do is we're going to first find r, your radius, which is just the square root of this one. So what's 1 squared? Plus this one over here, which is 1 squared also. And that just gives us a root 2. Now to find theta, your argument is going to be the tan inverse of this over here, which is 1, divided by this one over here, which is 1. So, which is just pi over 4. Hence, it will just become 1 plus I is equal to root 2 cis pi over 4. Done. Evaluate this, giving an answer in the form of this, where a and b are real numbers. Okay, we're probably going to use Demoivre's theorem here. So, this over here, we want to convert it to polar. So, root 3 minus I is what in terms of polar? Imagine, okay, so imagine square root of, so what's root 3 squared? It's just going to become 3. And this negative 1 squared, which is plus 1, and that will be 2. So it'll be 2 cis, and we want to find the angle. Remember, the angle is just going to be tan inverse of 1 over root 3 in this case, which is pi over 6. But be careful, if I was sketching this, so root 3 is here, minus I, it's going to be negative pi over 6. That's your angle for that one. So negative pi on 6. Let's write that down. Negative pi on 6. So this is that. Okay? And what's happened is it's been, so root 3 minus I to the power of 10 is just 2 cis negative pi over 6 to the power of 10. Now, we know that the radius gets actually, to the power of 10. It actually gets squared by to the power of 10 cis, whereas the angle just gets multiplied. So 10 times, so it'll be just negative 10 pi over 6, pretty much. Okay, that's that. Now, what about this one over here? Now, we already know what 1 plus I is. So we know that 1 plus I, again, was root 2 from the previous question, cis pi over 4. So what is 1 plus I, power of 12? It's just going to be root 2 to the power of 12, which is just 2 to the power of 6. 2 to the power of 6, cis, and that 12 gets multiplied with this, which is just 3 pi. Done. Now remember, they are being divided, so 2 to the power of 10, cis, negative 10 pi over 6, all divided by 2 to the power of 6, cis, 3 pi. Which is what? This cancels and we get 4 here, so 2 to the power of 4, cis, because now they're being divided, it's going to be this minus this. So for the angle, it's going to be negative 10 pi over 6 minus 3 pi. Now we can actually simplify that, which is negative 5 pi on 3 minus 3 pi, which is negative 5 pi minus 9 pi. Alright, so we're going to get negative 14 pi over 3. Negative 14 pi on 3. And we are nearly finished. Now the problem with this is it's not between where the argument of z has to be. Is, you remember, the argument of z must be between, the argument of z must be between pi and negative pi. Whereas this one over is not. So what we're going to just do is we're going to add 2 pi to it. So imagine negative 14 pi over 3. We're just going to add 2 pi, which is, 6 pi minus 14 pi, which is 8 pi on 3. Now, still 8 pi on 3 is still not inside, negative 8 pi over 3, we're supposed to say, yeah? That's still not in between this argument. So what we're going to do is, again, add another 2 pi. So we're going to add another 2 pi on that. 2 pi, we get 6 pi minus 8 pi, which is negative 2 pi on 3. Okay, so this we can rewrite it as just negative 2 pi over 3. Now, this is between the argument, so that's great. Now what we just want to do finally is get it in terms of Cartesian form. That's easy because, wait, 2 to the power of 4 is what? It's 16. Now, cis is just cos negative 2 pi over 3 plus I sine negative 2 pi over 3. Yep. Which is what? Now, think about it. Anything that's negative in the cos just becomes positive, so it's just cos 2 pi over 3. A negative inside a sine is just going to be negative I sine 2 pi over 3, because that negative just goes out. Okay, we get this. And what do we know? We know that 16... Okay, think about this. 2 pi over 3 is just pi minus pi over 3, which is in which quadrant? So if I see CAS, it's actually in here. Only sine's positive, so we have to write it as negative cos pi on 3. Minus I sine pi on 3. Okay, nearly done. Hence 16, what is cos pi on 3? It's negative half. And the other one's going to be negative root 3 over 2i. We are nearly done. Whoosh, that's a lot of work. Just going to move this over here. Okay. So, we got that. And multiplying that 6, it's just going to be negative 8 minus 8 root 3i. That is your answer, your final answer. Done. Next question. Let's use color. Find the gradient of the curve with this equation. At the point this, give your answer in this form, where a and b and c are integers. Okay, we're going to use implicit differentiation. So what we're going to do first is we're going to find the derivative of everything. So d dx, we have to d dx everything. 2x squared sine y plus d dx xy d dx pi squared over 18. Now, okay, here we have two things being multiplied, so we're going to have to use the product rule. So we're going to have 2x squared multiplied by the derivative of this, which is cos y. But remember, we've just derived it in terms of y. We have to multiply by dy dx. Yep. Plus sine y. The derivative of this is what? It's 4x. Done. So that's the derivative of that. Now let's go into this. Again, we're going to use the product rule because we have two things multiplied. So plus x, the derivative of y is just 1, but because we derived it in terms of y, we have to multiply by dy dx. Plus y, the derivative of x is just 1. So that. And the derivative of this is a constant. It's just 0. We are nearly done. So what do we do? Well, okay. Make the dy dx on one side. So dy dx is what? It's just 2x squared cos y plus x. Bring the other stuff on the other side. So it will be negative y, negative 4x sine y. Yep, so we've got that. Have I done any mistakes? Looks good. And then hence your dy dx is just negative y minus 4x sine y, all divided by 2x squared cos y plus x. Perfect. And now we just have to sub in and we find dy dx. Easy. Hence dy dx is what? So negative pi over 6 minus 4 pi over 6. Sine pi over 6 is a half. Divided by 2 pi over 6 squared. So just pi squared. 6 squared is 36. Cos pi over 6 is root 3 over 2. So root 3 over 2. Is that right? Yes, plus pi over 6. That's a lot of simplification, but it's not too bad. So we can get rid of the half. This makes it a 2 here. We can get rid of that 2. This makes it 3 here. So we're saying negative pi over 6 minus pi over 3. All divided by... Now this over here, the top just becomes negative pi over 2 pretty much. Negative pi over 2. All divided by this over here. Let's simplify it. We can get rid of these 2's over here. So it becomes pi squared over 36. Actually, bring that root 3 here. So root 3 pi squared over 36 plus pi over 6. Okay, nearly there. Now, I'm going to create a common denominator for these. So it's going to be... Actually, let me bring it over here. It's going to be negative pi over 2 divided by... So, root 3 pi squared plus... so if I multiply that, so we have 36 plus 6 pi divided by 36. Nearly there. So what we're saying is negative pi over 2 times 36 over root 3 pi squared plus 6 pi. And what can we get rid of? This becomes 18 over here. This pi can cancel out, so we get this. Hence, your actual answer is negative 18 all over. So negative 18 we get root 3 pi plus 6. That is your final answer. By simplifying it. Is that right? Let's have a see what's in terms. So a pi, so let's write this root pi root 3 plus 6. Where a and b, okay, yeah, these are all integers and pretty much that's your answer. Hope that's right. Perfect. Next question. Question 4. X and y are independent random variables. The mean and the variance of x are both 2, while the mean and the variance of y are 2 and 4, respectively. Given that a and b are integers, find the values of a and b if the mean and the variance of this are 10 and 44, respectively. Okay, so... Alright. Okay, so from the information, I know that the expected value of x is what? The mean is 2. Also, the variance of x is also 2. I know that the expected value of y, the mean and the variance of y is 2, and the variance of y is 4. Okay, and I know that the mean of this is 10. So the expected value of ax plus by. I'm simplifying this. This is the way you simplify it in your formula sheet. So what you do is take that constant out, expected value of x. Take that constant out, b, expected value of y. And we know that overall that is should equal to 10. So a, what's the expected value of x? It's 2. Plus b, what's the expected value of y? It's 2. And that is overall 10, which we can simplify as a plus b, 5. That's your first equation. Great. Now they tell us that the variance of ax plus by is equal to 44. Now we know how to simplify variance. So when you have a constant, it gets squared. So it'll be a squared, the variance of x, plus b squared, the variance of y, should equal to 44. And we know that the variance of x is 2, so we can write that as 2a squared. The variance of y is 4, so plus 4b squared. And that is all over equals 44. So we can get a 2 as a common factor. That gives me 22, and that is your second equation. Great. So we have two equations, and we solve them using, So what I'm going to do is, okay, look at the first equation. I know the first equation is a plus b is equal to 5. And what I'm going to do is, I'm going to solve for a. So a is just 5 minus b. And I'm going to pretty much put that inside over here. So 5 minus b squared plus 2b squared must equal 22, which will be 25 minus 10b, yep, plus b squared plus 2b squared equals 22. Have I made many mistakes? Have I made negative 10? So yep, negative 2. Looks good. So that will just be 3b squared minus 10b plus 25 minus 22, if we bring them 22 into the other side, equals 0. Hence 3b squared minus 10b plus 3 equals 0. So 3b, b, factorize this, we get 3, 1, put a negative both here. Looks good, so it'll be 3b minus 1, b minus 3 equals 0. Hence b is equal to 1/3 and b equals 3. Now this we reject because remember what the question told you. A and b are integers. So hence this we reject. So we can rub that out. So only b equals 3 is your value. Now that's good. Coming back to this equation. Just coming back to this equation. Your value of a is just 5 or minus 3. Hence a is actually just equal to 2. These are your values. Both are integers and they are great. Question 5. Sketch a graph of f of x, x plus 1, x squared minus 4, and the x is provided below. Label any asymptotes with the equations and any intercepts with their coordinates. Okay. So, we know to find the x asymptotes, we let the denominator equal 0. So, let's do that. So, x squared minus 4 equals 0, and we solve for the values of x. So, x is actually just going to be plus or negative 2. That's good. So, we have plus or negative 2. That is going to be one of your so one's going to be x, your x, both of them are going to be x asymptotes. This here will be x equals 2. And this one over here will be your other asymptote at x equals negative 2. Now, let's think. Do we have any y asymptotes? Do we have any horizontal asymptotes? The way we can check, because it's very difficult to have a look at this, what we can do is say, okay, what happens in the overall long term? So what happens if I sub in f infinity? Like what happens if I sub in the values of x infinity? It means, positive infinity. It means going to the right forever. What is this asymptotic behavior? Do we approach a value? If we do approach a value, it means that it's an asymptote. So let's do that. If I sub in, infinity, so it'll be infinity plus 1 all over infinity squared minus 4. Now, infinity plus 1 is just, think about it, like plusing 1 on infinity is just infinity. Think of infinity. And infinity squared minus 4 is just infinity squared. Now, look at this. Infinity over infinity squared. Now, we know infinity squared is much dominant. It's like so bigger. It's bigger than, this infinity. We can just simplify by saying, we can cancel this infinity. It's just like 1 over infinity. Now, okay, think about this. 1 over infinity. As the denominator gets bigger and bigger, what do we know that approaches? It approaches 0. So, in the long term, the y value should approach 0. So in the long term, as x approaches infinity, the y value approaches 0. So that is an actual asymptote. So that's great. So we know that there's an asymptote of y equals 0. We can draw that. Great. So that is y equals 0. Now, what I'm going to do is normally, this is what I would do in an exam. Okay, because they're telling us to find the, first I want to find the y coordinate. So imagine something, what's f of 0? That's going to be 1 over minus 4. So pretty much negative 0.25, which is, if this is negative 1, it's over here. Great, that's our point. And that's where it'll cross the y. What about any x intercepts? So x plus 1, x minus 4 equals 0. Now we know this just cancels out because, you know, if you multiply with 0, it's just 0. So that just becomes this equals 0. Hence, x is equal to -1. That is your x-intercept, so which is over here. Okay. Now let's look at this. We know that this is 1. Let's sub in what happens. So if I subbed in 1, 1 plus 1 is 2. 1 squared is 1 minus 4, hence 2, -3, which is approximately like -0.66, like around there. So if this is 1, this is 0. It's around here. So that's where that point is. What about if I sub in, let's say this point over here, which is, if that's 1, it's 1.5, which is -3/2. So 1 minus -3/2 to the value of x. -3/2, imagine squaring it, it's just 9/4 minus 4. -1/2 divided by 9 minus 16. -7/4. Half times 4/7. 2/7, and it's positive. So it means that in this point over here, 2/7. So 2/7 is very, very small. It's like, what's 0. Okay, 7, 14, 21. It's around like 0.28 or something. It's very, very small. So if I know, so it's like, okay, so that's 1, that's 0.5. It's approximately over here. Okay, so what I'm doing is just subbing those values in, and we can see that it should, in the long term, this over here, as we're approaching an asymptote, this asymptote, it can't cross it, so it's going to go like this and go up, as we can see, likely to go up. Great. I want to check if this, if I sub in this, does this get lower? So that point is 3/2. So 3/2 again. So 3/2 plus 1, 9/4 minus 4, 5/2 divided by 9 minus 16, -7/4, 5/2 times -4/7, -10/7, which is like -2 point, so -1 point something. So that point is over here, around there. So, okay, that's just telling me, because it's approaching the asymptote, we can see, it's probably going to go like this, and it's going to go down. Great. And what about these values over here? What about if I sub in like 3? Let's sub in 3. That'll be 4, 9 minus 4, 4. 9 minus 4 is 5, which is, this is 0.8. So if I sub in here, and that's 0.8, this one is approximately here. What about if I sub in like this point over here, which is 2 plus 0.5, so 2 plus half, which is 5.5/2. So let's sub in 5/2. 5/2 plus 1, 25/4 minus 4, 7/2, 25 minus 16, which is 9/4, 7/2 times 4/9, hence 2, 14/9. So it's approximately like 1 point, so it's greater than 1, it's around here. So okay, and if I sub in, what about if I sub in a value here? If I sub in like this point over here, which is, and that's 3, 1 more point, so 3 plus half, 7/2, so imagine 7/2 plus 1, 49/4 minus 4, and 9/2 divided by 49 minus 16. Okay, which is what? 33. So 33/4, so 33/4, 9/2 times 4/33. 18/33, which is very small, but in the positive. So it's actually approaching, okay, now that makes sense. So what's happening is, it's approaching y equals 0. So as we can see, the more we get a greater value, we're approaching that the asymptote y equals 0. And pretty much it should have, like, subbing, what about this one over here? If I sub the -3, this point over here, let's see. Like, 1 minus 3, 9 minus 4, -2, 9 minus 4, which is 5. So it's the same thing, but now it's in the negative. Sorry, it's it's like the same thing, but it's now in the negative. So, okay, that's all right. So, 40. So if I know that 5 looks like this, it's like that, like this. So it looks symmetrical to this one over here. Is that symmetrical? By symmetry, they should be like, yeah. So this will approach that, and it'll go down like that, and that's it. Those are it, and we just need to label our x-intercept. So we know that this point over here is what? -1, 0. This point over here is what? 0, -1/4. And that's it. Easy. Hope that kind of helps you understand the question. So that's good. When you don't understand, try plotting some points and look at the behavior overall long term. Question 6. A particle of mass 2 kg moves under a force F so that its position, vector r, at any time is given by this. Distances are measured in meters and time is measured in seconds. Find the change in momentum in kilogram per meter squared from t equals 5, so pi over 2, and t equals pi. Now we know that the change of momentum is just mv minus u. Now we have this position vector, so if we know that the derivative of it, so the derivative of the position is just going to give us a velocity. So that's going to be cos ti minus sine tj plus 2tk. And if I sub in the initial velocity minus so your final minus your initial, so your initial would be at this time and your final will be at this time. So let's find the initial velocity. So u in this case is just equal to r dot of t when it's pi on 2, which is what? So let's think about it. If I was drawing cosine, and if I was drawing sine. Okay, let's think. This is 2 pi here. This is 2 pi here. So if I sub in, cos pi over 2. So cos pi over 2 is, in my case, 0. So that's 0. What about if I sub in sine for this one here? So sine pi over 2, we know that sine pi over 2 is 1, so it would be negative j. And, subbing pi over 2 here will be just plus pi k. Done. And what your final velocity is just your r when you sub in pi as time. So cos pi is negative, so it'll be negative I, negative 1. If you sub in sine of pi, it's 0. And if we sub in that pi, it'll be plus 2 pi k. That's nearly done. So we've got those final and initial velocities. Now we just use the formula. Your change in p, your vector, change in p, it's the mass, which in this case is 2. Your final velocity, negative I, plus 2 pi k, minus your initial velocity, which is negative j, plus pi k. Like, simplifying this, like, let's simplify the inside, let's simplify here. So we have, negative I plus 2 pi k plus j minus pi k. Negative I plus j plus pi k. Hence, your change in p is negative 2i plus 2j plus 2 pi k. That is your answer for that one. Nice. That's your change of momentum. Great. Question 7. Given that cotangent to cot of 2x is equal to this, it's equal to some value called x, use a suitable double angle formula to find the values of a. Okay, so we need to use a double angle formula. We know that the double angle formula for tan, like 2x, it's in your formula sheet, is equal to tan of x divided by 1 minus tan squared of x. Okay? So in this one, cot is just 1 over tan, so imagine like 1 over tan 2x. Now we know tan 2x is this. Imagine just reciprocating that. So hence just, that's going to be 1 minus tan squared of x, all divided by 2 tan of x. What about this one? It's just plus tan of x, all divided by 2. And we simplified that so we can get this. So let's think about it. So this is the left-hand side. If I multiply both sides by 2 tan of x, if I multiply this side by 2 tan of x, we get just 1 minus tan squared of x. If I multiply, this one here by 2 tan of x, we'll get plus tan squared of x, all divided by 2 tan of x. These cancel out. That's great. So we just get 1 over 2 tan of x, which can be written as half cotangent of x. And that's it. So the value of a in our case would have been a is equal to half. Given that this, use similar to find the value of a. Yeah, your a value is a half. Nice. Next question. Question 8. A tank initial holds 16 liters of water in which 0.5 kilograms of salt has been dissolved. Pure water then floats into the tank at a rate of 5 liters per minute. The mixture is stirred and continuously flows out of the tank at a rate of 3 liters per minute. Okay, show that the differential equation for Q, the number of kilograms of salt in the tank after T minute, is given by this. Okay, you should know how to do these kind of questions. So they're like mixing questions, and they are pretty much like, they come up in the exams a lot, most of the exams. So you need to know this formula. That's very important for these kind of mixing questions. So to find dq dt, which is like, the change in mass over time. Okay, this is what you need to know. dq dt is what we want to find. It's the actual dq is equal to dq dt in minus the dq dt out. So, okay. This is your actual formula that will help you. So what is our dq dt in? It's actually the rate in flow. So what is the rate that the water, what is the rate that it's flowing? So rate in, so what is the rate that it's flowing? Multiplied by the concentration, which is normally in mass over volume. So let's have a look at this. We know, concentration, mass over volume, which in this case, it's concentration, mass over volume. It's a concentration. Remember concentration? It's mass over volume. So we'll try that at C, actually. At C, your concentration. Well, we know that for dq, we know that initial holds this, which is pure water. So pure water. Now, what do we know about pure water? Pure water has 0 concentration. So your concentration, the pure water then flows into the tank. So we know the rate in that flows is 5 liters. So rate in is 5. It flows in 5 times the concentration, which in this case is 0 because it's pure water. That's 0. Hence, that overall is 0. That's great. Now let's find dq dt out. What is coming out? Remember, it's the rate out. So it's the rate out times the concentration, which is, remember, just m over v. Okay. Now, what is the rate out in this case? The rate out, so the mixture is stirred continuously and flows out of the tank at 3 liters per minute. So we have 3 times. Okay. What is the mass? Remember, we're taking Q as mass. Q divided by volume. So, okay. For this volume, this is how you actually calculate volume. So for this volume is the initial volume, for example, the initial volume, plus the rate in minus rate out That is your actual formula. So for example, we know that the tank initially holds 16 liters. So it'll be volume 16 plus. What is the rate in? We know that the rate in is 5. So it'll be 5 minus the rate out, which is 3, multiplied by T, which is 16 plus 2T. Great. So let's rub this out. And that gives me 3Q over 16 plus 2T. Now, putting these all together, remember dQ dt is the rate in minus rate out. dQ dt in minus dQ dt out. So, hence your overall, let me move this, all of these little ones over here. Hence your overall equation. Hence your dQ dt is the dQ dt in, which in our case was 0, minus dQ dt out, which is 3Q over 16 plus 2T. Now, 0, we can get rid of it. There's no need for 0. Yeah, and it's the same equation as what we're told. We've shown it. Done. That's how you do it. Great. Next question. Solve the differential equation given in part A, okay, to find Q as a function of T. Express your answer in this form, where A and B and C are integers, positive integers, okay? Let's do that. Okay, let's use, blue. What I'm going to do is, okay, so let's write that. dQ dt is negative 3Q over 16 plus 2T. What I'm going to use is separation of value. Remember, we have Q and T. We're going to have to use separation of variables. So when we separate those, it will be the integral, so nicely, the integral of 1 over negative, well, I'll show you how I do this kind of question. So what I'm going to do is, okay, I'm going to split this apart. I'm going to get Q in one way and a T term. So for example, this here, I'm going to rub the top, multiplied by negative 3Q. See, this is in terms of Q, whereas this is in terms of time. So this way you do, so the integral, first is the Q value. It's going to be the reciprocal of the, and whatever it's in terms of Q, which is negative 3 over Q. We can put that negative there. 3Q dQ, using separation variables, is equal to the integral. And this one just keep it normal, so 1 over 16 plus 2T dt. We want it in 16 plus 2T, so I don't think we should take a 2 out in this one. Okay, so integrating this will be negative 1 over 3 log E absolute value Q. Now, we know Q is greater than 0 because it's mass. Remember, mass has to be greater than 0. So we don't need those absolute values anyway. Is equal to what? So 1 over the derivative of the bottom, which is just 2, log E absolute value 16 plus 2T. Now, guess what? T is greater or equal. So you remember T is greater or equal to 0. So it's always positive and it's always going to be added with positive. So we don't actually need also absolute values for this one. That's great. And we're going to plus C. Okay? Now I'm going to get rid of this negative 1 over 3 by multiplying both sides by negative 3. So it'll be log E Q. It'll be negative 3 over 2 log E 16 plus 2T. Now, you multiply by C, it just C is a constant. We'll solve afterwards. Yeah, let's solve it now, actually. Let's solve C now. So, what do we know? What is our initial condition? We were given that initially it holds 0.5 kilograms of salt. Initially, so when T equals 0, it's 0.5. So, let's do that. So, what it means that Q of 0 is just equal to a half. That is your initial condition. So, let's write that down. So, log E of half is equal to negative 3 over 2 log E of 16 plus C. We can get that, just write it as the negative log 2. Okay, now this, if I bring this forward here, what happens to it? So it's like 16 negative 3 over 2. So it's like 1 over 16 3 over 2. 1 over 4 to the power 3. 1 over 6, 12, 18, 20. Yeah, 1 over 64. So that is what it becomes. Wow. Okay, so wait. If I bring that there, and then that's 4, then to the power 3, which is 16, 6, 12, 18, 24, so it's 1 over 64. We can write this as log e 1 over 64, which we can actually just write it as 64, but put a minus in front of it. So minus log e, so it would be minus log e 64 plus c. And then we calculate the value of c. Now, okay, so let's think about this. If I know that, think about this, 64, we want to get it like into, like, imagine, so we know it's 4 to the power 3 64, yeah? And 2 squared, so this here is 4, so 4 to the power 3, so it'll be just 2, 6. It's 2 to the power of 6, so if this is 2 to the power of 6, and I can bring that 6 forward, so it'll be negative 6. Log E2 plus C, hence we can actually calculate the value of C very nicely here. So C is what? It's 6 log E2 minus log E2 equals C, hence that's 5 log E2 equals C. So we got the C value. Nice. Wow. I'm going to take this whole thing over here and just put it somewhere. Make it very small. Put it over here. So now we can get rid of this and just say our C value is 5. Oh, well, let's write it just log E of 2 to the power of 5. Now, great. So I'm going to bring that, rewrite this as log E of Q. I'm going to, so log E of 16 plus 2t to the power of negative 3 over 2. Now, because they're being plus these two logs, it's just the same, multiplying that. 2 to the power of 5. Now, because both sides have logs, we can get rid of those logs, so it'll just be Q. It'll be 2 to the power of 5, which is what? It is 32. Divide 16 plus 2t negative 3 over 2. Hence Q is 32 over 16 plus 2t 3 over 2. Have I made any mistake? Where A and B are positive integers, they are positive. Yep, they're all positive integers. That's great. That's your answer. That's right. Great. Question 9. Let's have a look at this. Let's use a, I don't know, let's see what nice color we can use for this one. We'll use this color. A curve is specified parametrically by this, where t is an element of all reals. Show that the Cartesian, why would it say t is an element of all reals? I think they made a mistake here. It's supposed to say probably, they've made a mistake. They're supposed to say plus, including 0. You just should have wrote that. I think they made a mistake with that one, but because t is greater or equal to 0. Show that the Cartesian equation of the curve is given by x squared minus 2y squared equals 1. Easy. So we know that our x is secant t, so I your I component, and your y is the j component, negative 2 over 2 tan of t. Now, what do we know? We have secant and we have tan. You should know, looking at your formula sheet, that there is a relation. It is 1 plus tan squared of x is equal to secant squared of x. So secant squared of x is just x squared. So x squared is secant squared of t in this case. And if I rewrite this as 2, so actually If I multiply both sides by 2, so 2y over root 2, which we get this, tan of t, and imagine squaring it, we get 4y squared over 2, which is 2y squared. 2y squared. That's it. And then I've squared, yeah, so this 2. That's pretty much, and putting it all into this relation, we get 1 plus 2y squared is equal to x squared. So hence, x squared minus 2y squared is equal to 1. So this is a, yeah, that's it. We've shown it. That's actually a hyperbola. Find the x-coordinate of the point of intersection of the curve this and the line this. Okay, easy. So, if this is in terms of y, what I can do is I can shove it into here. So, x squared minus 2y. X minus 1 squared equals 1. Hence, x squared minus 2, x squared minus 2x plus 1 equals 1. X squared minus 2x squared plus 4x minus 2 equals 1. Okay, so that'll be negative x squared plus 4x minus 3 equals 0. Hence we can write it as x squared minus 4x plus 3 equals 0. So it'll be x, 3, 1, negative, negative. We get x negative 3, x negative 1 equals 0. Hence, x is equal to 3 and x is equal to 1. Those are your x coordinates of the points of intersection. Nice. Question C. It says find the volume of the solid revolution formed when the regions bounded by the curve and the line is rotated about the x-axis. So, what they're saying is, okay, let's draw this hyperbola. The hyperbola looks like this. So if I was drawing this, okay, I don't know, like, well, this is not the, something like this. Now with the hyperbola, okay, is here because it's and they're both divided, but think of it as 1, so it'll be moved 1 unit like this here and here. So the hyperbola looks like this, something like this, that, like that. Not the best, but yeah, something like this. And whereas this is 1 and this is negative 1, and this line over here is what? It passes through negative 1, so it passes through like this. Something like this. Remember, this is going to move like this. And so we found the point of the coordinate of intersection. So we got here, and we also got here, which is 3. Okay? So what's happened is, find the volume of the solid revolution formed when the region bounded by the curve. So this region here is rotated about the x-axis. Imagine it's like, rotated about the x-axis. It'll look like pretty much like this. So imagine this and something like that. Yeah. So don't get too stressed. So what you just do here in this case is, okay, let's think. For a question like this, we know that finding volume, it's always volume is pi integral, because you rotate about the x-axis. Think of it. You have to write dx, and these values has to be values of x. Well, in this case, we're going from 1 to 3. So we write 1 to 3, and normally inside is y squared. But because we want to find the region that's like between, normally when we like find the area of a region, we always get the upper function minus the bottom function. So just do the same thing. So for example, what is this upper function? Well, our upper function for this case is this hyperbola. So let's look at the hyperbola. Hyperbola is this, which is x squared minus 1. If I bring it over here, divided by 2, and that gives me my y squared. Great. So let's write that down. x squared minus 1 over 2 minus the volume that we generated of the straight line, which is y squared. So x minus 1 squared, which, let's all do it all together. So like this x squared minus 1 over 2 minus x squared minus 2x plus 1. So x squared minus 1 over 2 minus x squared plus 2x minus 1. X squared minus 1 minus 2x squared plus 4x minus 2. We can minus x squared plus 4x minus 3 all over 2. Okay, done. We've just simplified it. So we can get that 2 out here. Hence, we just get negative x squared plus 4x minus 3. Done. I'm just going to get rid of all of this. This is too much confusing. There's no space for that. Okay, we got this. Now we just need to integrate this. Wow. Okay, so volume will be pi over 2 of negative x to the power 3 over 3 plus 4x squared over 2, which is just 2x squared, minus 3x. Okay, from 3 to 1. Hence, your volume will be pi over 2. Well, okay, so if I sub in 3, it'll be negative 9. Plus 2, so 3 squared is 9. 9 times 2, it'll be plus 18. If I sub in 3, so negative 3 times 3 is negative 9. So first, minus negative 1 over 3 plus 2 minus 3. Okay? Hence, your volume is pi over 2. Alright, so these cancel out because negative 9 minus 9 is negative 18 plus 18, 0. It'll be 1/3. 2 minus 3 is negative 1, so plus 1. Hence, your volume is pi over 2. So 1 plus 3, so 4 over 3. Nearly there. You can cancel that to 2. And so volume is just 2 pi over 3 units cubed. That's it. That is your answer. Done. Last question, yes? Yes. The position vector of a particle moving along a curve at time t seconds is given by this, where t is between 0 to 1, where distances are measured in meters. The distance, d meters, that the particle travels along the curve is in 3/4 of a second is given by this. Find the values of a and b and c, where a, b, and c are integers. So, okay, full numbers. All right. We're finding the distance, so we're going to use the arc length. So we know that the arc length formula for distance, especially with parametric equations like these, is going to be, is normally the formula is distance is the integral of dy dt squared. It's in your formula sheet, so dx dt all squared. That is your distance. And like it's the integral pretty much, yeah. The integral from what value of x you're going to go to what value of t, sorry. So distance is that, t1, t2. That is your formula. So, okay, let's find. Well, we know this is your component, so it's x is equal to t to the power 3 over 3. And, finding the dx dt, so dx dt would be what? It will be dx dt t squared. Okay, great. And then squaring it, so dx dt all squared t to the power 4. Great. Now let's find, we know that y is equal to what? Sine inverse of t plus t square root 1 minus t squared. Okay? Hence, dy dt, so the derivative is going to be 1 over the square root of 1 minus t squared. And here we're going to use the product rule because there's two things multiplied. So u is t, so we'll keep t here. Multiply by the derivative of this. Now you should know, derivative, well, okay, I'll tell you one thing. If you have a function and you want to find the derivative of, say, f of x, and you want to find the derivative of this whole function, when it's inside the square root, it's going just to become f dash of x divided by 2 f of x. That is the formula that I'm going to use. This is the fastest way. You don't have to use the chain rule. So, for example, f dash of x is the inside function as well. It's going to be negative 2t divided by 2 square root of f of x, which is just 1 minus t squared. Done. Now v is just, again, this. 1 minus t squared. Derivative of t is just 1. So great. This is that. Okay, what can we do? Well, let's simplify it. So 1 over square root 1 minus t squared. These cancel out, so we get minus t squared square root 1t squared plus square root 1 minus t squared. So I'm going to multiply everything by 1 minus t squared. So we get 1 minus t squared plus 1. So plus 1 minus t squared all over square root of 1 minus t squared, which is equal to 2 minus 2t squared all over 1 minus t squared. We can take a 2 as a common factor, so 1 minus t squared over square root of 1 minus t squared. Now, guess what? Both of them have 1 minus t squared, so remember this is to the power of 1, whereas this one over here, you can write it as, because it's in the square root, it's going to be 1 minus t squared half. So what's 1 minus a half? It's just a half. So we can rewrite this like this, a half. And, okay, which is that? And then what we want to do, so that's your dy dt, and remember we want to square it. So hence your dy dt squared is what? It's just squaring this whole thing is just going to be 4 1 minus t squared. And we know we have to add them from here. So let's add those together. So your dx dt squared plus dy dt squared is, like, expanding that. So dy dt, so it's just going to be 4 minus 4t squared. And the other one's plus t to the power of 4. And then imagine, so squaring that overall. Squaring this whole thing. Okay. And yeah. And we want to make sure it's in this form. So, this over here, have a look at this. If I can take this, it's square root t to the power 4 minus 4t squared plus 4. Now think about this. If I let u equal t squared, I can rewrite this whole expression as, like u squared minus 4u plus 4. See, this is a quadratic and it's a perfect square. So we can actually rewrite this as u minus 2 squared. And remember, u is t squared, so imagine just putting back t squared there. And there we go. And imagine squaring it, because it's in power of 2, it just cancels out. But be careful, this is where a lot of students make that mistake. Remember this basic formula. When you have, say, something like x squared, and normally, when you take like the square root of it, you just think it's like x. Now, you're not wrong by saying that. That's true. But that's not the full case. There could be, say, for example, it's actually two cases. We have to write plus or absolute value of x. And why is there two cases? Let's think about it. If for example, I had, say, the square root of 4. Yeah? And, like, for example, that's 2 squared. So, like, it will be equal to 2, yeah? Now, in any case, like, for example, this thing we could have, why do we have to put the absolute value, like, normally when we, like, think about it? So, wow, it's actually hard to explain. So, for example, if I had, so we said x, it's just equal to the absolute value. Think of it. If I had, say, -2, imagine squaring both sides. What happens? 4. -2 squared is what? It's 4. So they are equal. So there's actually, there's negative and positive values of, so whenever, okay, this is a basic formula. I know it's very confusing, but overall, if you have a square root of, something like x squared, it's actually equal to the absolute value of x. Now, in methods, this is not the case. We always take, as x is greater than 0, we always take the positive. We don't deal with absolute value. But for special students, you need to understand the absolute value. What does it mean? And yeah, so here, this is just going to be the absolute value of t squared minus 2 absolute value. Great. So think about it. So we've got that. And we know that t is 0 to 1. So let's draw this. If we were drawing this, now, how does this look like? Now, t squared -2 is going to look like this. And what happens when the absolute value of a function? So this is here, it's just like y equals t squared minus 2. The absolute value is just anything that's at the bottom gets to the positive, like it becomes positive. So this whole thing gets reflected. Now the red part is the absolute value of y, which is just absolute value of t squared minus 2. That's our function. And, okay, see the problem with this, and I'll tell you why there's a problem. If you took the blue graph, example, this case, we're not thinking, we don't see, for example, what am I saying? Oh my God. We're taking the area from 0 to 3 over 4. And so this is root 2, and this is negative root 2. And so the area of like 3 over 4 is approximately here. Let's say it's here. So if we were using the blue graph, in this case, students would have forgot the absolute value. If you're using the blue graph, what happens? You'll get you'll calculate the area of here, and that will be your distance. Now, but guess what? We know that distance is greater than 0. We cannot have negative distance. So that's why the absolute value is so important for you guys. If we had the absolute value, we would have done this. We've took that red graph, and we've got this area, which is the positive distance, and that's why you need the absolute value. So, yeah, pretty much that is why. Okay. So we need that one. So, okay, how would the graph look? So when we simplify this, to get rid of those absolute value, we know the absolute value is just plus or negative x. Just to get rid of those absolute value. If I wanted to get rid of those, So if I wanted to get rid of an absolute value, all I have to write is plus or negative 6. So we have two cases. So in this case, let's think about this. I want to get rid of those. So I'll write plus or negative t squared minus 2. Okay. Remember, this was the positive. We took the positive. And guess what? It was the blue curve, which was wrong. So hence, we have to take the negative, which is 2 minus t squared, which is this graph over here. And yes, it does make sense. So hence, your overall answer... So hence, overall answer is, yeah, t minus t squared. So t minus t squared, which is... We want to find values of a and b, so hence the value of a, which do we have squared? Yeah, which is -1. B is 0. C is equal to 2. And that's it. Those are your answers. I hope that makes sense, yeah? I hope I actually explained it all right. I'm sorry if it's a very, very bad explanation, but yeah, that's why this question was probably one of those 5 markers, because it kind of did trick a lot of students. So I hope that helps you. Thank you guys for watching this video. Please make sure to like and subscribe for more future videos, and good luck to you guys. Have a good day. Bye bye.